Good afternoon, everyone. We here. Turn this down a little bit here. My background music. Okay, let me see. Who do I have here? Is this Nobia? Who is this? Turn your camera. Let me see this. Who's this?
Hello, Dr. Reed. I was in your rotation today.
Girl, you know you're on the stage of my show.
Sorry.
You're my podcast. Girl, you crash. How you crashing my podcast? What's your name anyway? Show yourself at least.
Okay. Yeah. I just got your link. I don't know. I wasn't sure.
You're live on the podcast now, so okay, I'll show you. So the first link is if you want to participate, and you can certainly participate if you want to. Okay. And then other than that, then the second link I gave you a link to just the YouTube channel, and then you can just see the YouTube.
I was just asked that I'm supposed to come here. I didn't know.
No, they set you up. They said, yeah, click on this link.
Okay.
But you're welcome to stay if you want and everything, or I can just remove you and say which one I can just remove you, okay? And then you can just hit the link to the YouTube, okay?
Okay, thank you. Thanks so much.
Nice to meet you, okay? Okay, and then Ali. You hear Ali? Turn your camera on, Ali, because I think you're on the stage also. How you guys doing today? I'm gonna wait a few minutes so that so a couple other people come in, maybe one more, because I go viral when I get like 6 views. I'm 6 views. 6 views, I'm viral. So we're gonna have a really interesting discussion today, and I'm going to keep the discussion hopefully confined to around 20 minutes. This is going to be on the basal ganglia, on the temporal lobe. I've been going through the different lobes of the brain just to give you some idea of the different hemispheres or the different lobes what they're responsible for. And so let me see here. We're going to go through the temporal lobe, okay? Okay, so just explain the temporal lobe, just a brief overview. Then we're going to go through the receptors and then the nerve fibers running through there. Okay, I'm all over it. Okay, where I'm at here. Okay, I didn't want to sign up for it. Let me just try the new chat. Okay. Temporal lobe. All right, let's get into it. Okay. Now, the reason why this is important, patient or anyone presents with certain sets of moods or type of behaviors, you need to have a good sense of what parts do what. And so you can sort of narrow it down at least to the hemisphere or the region. If you understand the hemisphere or the region, if you understand the blood supply, the nerve supply, and the receptors on those nerve bundles, then I think you have a really good idea of the routes you'll need to take to deliver the medications to these particular targets. And so we need to know exactly when we give the medication, we need to know exactly the endpoint of exactly where it's going to target it and what it's going to do. Otherwise, we're just guessing, right? If you don't really know the target of your medications. So here, the temporal lobe is one of the 4 major lobes of the brain, located on each side of the head. On each side of the head. This is really written so you can really understand it, below the temples and behind the ears. It plays a crucial role in several key functions, primarily related to auditory processing, memory, language, emotional regulation. Broca's area is over here. Here's this language, in this emotional area here. Below is a clear and concise explanation of temporal lobe. Its anatomy, function, and significance. Okay. the anatomy of the temporal lobe. First, let me show you what it looks like. Temporal lobe. Here we are, right here. So here we are, right here. Remember, when we looked at the networking, we was looking at the inner surface of the brain. Let me see if they have another. Okay, like this. This is the inner surface of the brain, and this is the outer surface. You know, remember when we were looking here, we were looking at the nerve fibers come up here. So when we were looking at the inner surface of the brain here, that's when we were able to look at the mesocortical pathway that goes along here. You know, we look at the mesolimbic pathway that goes along here. So in the inner surface of this brain, you can see that's where we have the networking. And this is the outer surface, like here on the outer surface of the brain here. That's what we have there. Okay, so this the frontal lobe right here. Okay, I mean temporal lobe. The temporal lobe is situated beneath the lateral sulcus, the sylvian fissure. Okay, let me show you here. The sylvian fissure here. I think this is it right here, right? I think that's the sylvian fissure right there. Correct me if I'm wrong. Sylvian fissure. Yeah, I believe this is the sylvian fissure right here. Okay. Which separates it from the frontal and parietal lobes shown above. The frontal lobe, which is here. Yeah, the frontal lobe here. And the parietal lobe, which is here. And I think this is the sylvian fissure right there. You know, it's the part where the tissue sort of envelops on itself. It's a lobule. Okay. It borders the occipital lobe at the back. It is divided into several key regions. The superior temporal gyrus, auditory processing language. Okay. The medial and inferior temporal gyrus, visual processing, object recognition, and memory. Right? The medial temporal lobe includes structures like the hippocampus and the amygdala. I kind of thought that the hippocampus was set apart from the medial temporal lobe, but the medial temporal lobe includes structures like the hippocampus, and thus we reviewed the hippocampus primarily for memory, and then the amygdala, the emotional processing center here, and this is simply just a subnuclei within the temporal lobe. Okay. Auditory cortex, located in the superior temporal gyrus, processes sound information. Okay, Wernicke's area. All right. Typically with the left temporal lobe. Wernicke's, yeah. Essential for learning language comprehension and speech production. Remember Wernicke's encephalopathy? Yeah, temporal lobe area. Okay. The temporal lobe is highly connected to other brain regions, such as the limbic system. Yeah, I can imagine for emotions and memory, and the frontal lobe for decision making and planning. Can you see how it makes sense? You know, can you see how all of these lobes, they specialize in processing specific types of information, right? It does it in this cortex, and then it integrates it back into these centers that sort of process things. Okay, hold on 1 second. Just gotta send this text real quick. Okay, so you have the specialized centers that are specialized in processing only like one type of information, like the visual cortex only does the visual cortex, right? The auditory is only that type of information. And then it integrates it into these areas right here. So here, the temporal lobe is highly connected to other brain regions, all right, such as the limbic system. Of course, you're going to need to get emotions, right, and memory to your limbic system and frontal lobe decision making and planning. Key functions, okay, auditory processing, yep, language comprehension, memory, visual processing, and object recognition. Hey, Doc, how's it going? You're not on the stage yet, but how you doing, Doc? Hold on a second. So I believe I can still hear you. Can you say something, Doc, so I can hear you? So I think, let me see here. Okay.
So I know I had a good time. That's what I'm saying.
Oh, okay. Okay. Great. Hey, Faith, thanks for joining me. What I'm doing is that every day at noon for the students and for my patients, I'm going through the science behind psychiatry and neuropsychiatry. And so here, this is on the temporal lobe. And so I'm going through how it works, and I'll go through how it functions, the blood supply, the nerve supply. And then I look at the receptors, and I use the AI because it puts everything. Oh, it's amazing. It's amazing. So yeah, hey, jump in. Let me know if you want to be on active on the stage, or you can just contribute, or you can just stay audio, whatever you're comfortable with. Okay.
So how long gonna be this podcast? Hour?
I try to do these for the students around 20 minutes because they don't have enough time. So I try and keep it below 20 minutes for the students, because they're not gonna watch it if it's like 45 minutes. So I'm trying to get it in for 20 minutes.
Yeah, no problem. I'm free now, So
okay, thanks for showing up, Doc. Okay. So here, visual processing, emotional and social behavior, olfactory processing. Okay, so let me just go through some of these. And so it's important to understand the function of this frontal lobe because when the patients come in with these type of issues, like if they're not really listening to what you're saying, or not really able to comprehend or process what you're saying, that's a real issue. In order for someone to really understand what you're saying, that information needs to be encoded into their hippocampus first. And then those bits of declarative information is sent more to the prefrontal cortex to be rendered into some type of reality. But the thing is that if the thing you're telling the person never gets encoded in their hippocampus and sent for processing, it never gets rendered into the reality that you're trying to make. So you have a reality, you're talking to somebody else and say, please, can you get that? You said over and over and over. It's not getting into their system. So when they come up with a reality, it's a complete reality that's void of any of the items that you were arguing about or you're angry about. And this represents dysfunction in the parts of the brain, and necessarily not the person being uncooperative or oppositional or defiant or anything like that. It's real. This language is about information processing. And if you are only, and you have more awareness when you process, let's say 100% is the most awareness you're going to have, sometimes people can only get like 10% of the information you're saying. And if you don't recognize that they don't have the capacity to put more information into their system, then I'm not sure how you're going to develop a reality that's stable enough for you to actually communicate, that's close enough for you to actually have a relationship and communicate. So here, auditory processing, the primary auditory cortex, right? Processes sound information, including pitch, volume, and tone. All right, pitch, volume, and tone. Recognizing a friend voice or identifying a song. Remember, what is that syndrome? I know I got a lot of students around, so I know you call this out if I say it wrong. Capgras syndrome or something like that. I think imposter syndrome. It was the someone wake up with the type of brain lesion, they believe that they don't recognize their loved one's voices or things like that. I'm not sure if it's the same one, but I recall that. Here, the primary auditory cortex is here in the temporal lobe. Language comprehension, Wernicke's area, right, is crucial for understanding spoken and written language. Here, damage to this area leads to Wernicke's aphasia, where individuals produce fluent but nonsensical speech and struggle to understand language. This symptom I never get right. When patients present to me with Wernicke's encephalopathy, it's hard for me to pick that up. It's hard for me to grasp it when I see it, and so I usually make errors first. I usually think it's something else, and when things don't work out, I have to go back and sort of review this and try to look for these type of aphasias. Yeah, but when a person speaks fluently and none of it makes any sense, if it's fluent speech and you can't comprehend any of it, then we're talking about there. Here, memory, look, hippocampus, right? Medial temporal lobe, essential for forming and retrieving memories, particularly declarative meanings, objects, just the facts, not abstract concepts. Like, you can't find love in memory. You find a chair in memory, right? A chair. Your declarative meaning is a chair, not how you feel, your wishes or your ambitions. It's a chair. It's an object, something like that. Okay, so these cortex here consolidate memory. Okay, next we have visual processing and object recognition. Okay, I never get into these. Okay, emotional and social behavior. Yeah, here it is, the amygdala, located deep within the medial temporal lobe, regulates emotions, particularly fear and pleasure, and plays a role in emotional memory. And then olfactory processing. So here, I just wanted to go through a few. It seems like there's more information here, but left versus right. The temporal lobe exhibits functional lateralization. The left temporal lobe dominant for language, right? Speech comprehension, verbal memory. I think that's Wernicke's aphasia for the left, right? And right temporal lobe involved in nonverbal tasks such as visual memory, spatial processing, and music perception. Yeah, right. Yeah, very interesting. And let me know if you have any questions, or if you want to make any comments, just let me know and I'll be able to sort of update things from there. But let me know if you have any other questions. And Dr. Rahman, did you have any? Would you like to be on here or just the sound?
It's okay. I mean, I'm in the room, so no problem.
Okay, I didn't know if you're the type of doctor that hides all the time.
yeah. I can shut it off if I want. It's an option over here,
Yeah, you have people who don't want to be seen. Okay, all that everything. Okay, but you're doing okay, no, Doc?
Yeah, I'm doing okay,
Yeah, and I know I just dropped this on you like 5 minutes ago, but any comments about the temporal lobe or anything like that? And what you say?
Yeah.
Okay, let me just introduce you. Me and Dr. Rahman work together. He's the medical doctor. I'm the psychiatrist, and we work as a team. And we provide very good care for our patients and our students, and education for our students. And so we're looking for ways to sort of improve our care and so we're going to focus on educating our patients, and families, and the students. And so me and Dr. Ron, we work together, and we've been working together for a while. Hey, it's been a pleasure working with you, buddy.
Thank you. As long as you're with me, I'm fine with you.
Any thoughts about
a good team?
Yeah, any thoughts about the temporal lobe and things like that?
Yeah, I know. I just had to do what receptor is the prominent over this? Dopaminergic or serotonergic? What is the most common over there?
I think it's dopaminergic.
Okay.
But let me just see, because we're going to go over the receptor profile. Let me just try that now. What is the See, I'm trying to make it useful for the students in the USMLE. So
yes, they have to familiar
things that they will find useful. And so let me just review this real quick. So guys, remember in the temporal lobe, we went through the hippocampus, we went through all the cortex, we went through all of these lobes. Remember, the same concept applies. Glutamate is the main excitatory neurotransmitter. It's present throughout all the tissues. GABA is the main inhibitory neurotransmitter. Those are the main activation, deactivation, things like that. And then you have things like norepinephrine, serotonin, acetylcholine, alpha adrenergic receptors. And I would say those are very significant receptors, but those are primarily localized within the area. They're not generally just well distributed throughout the body as glutamate and GABA. And so look here when it comes to the temporal lobe. Look, glutamate receptors. Right? Glutamate receptors, look, GABA receptors, right? And then here's our host of other receptors. Acetylcholine, look, attention, learning, and memory, right? The dopamine receptors. Remember, this amygdala and hippocampus, remember the dopamine, if we need to stabilize that mesocortical pathway, or if we need to stabilize that mesolimbic pathway, here are again, dopamine receptors in the frontal lobe also. Here we are again, serotonergic receptors. Cannabinoid receptors work here. I don't know too much about the cannabinoids. Yeah. So any what do you so Doc, here are basically the receptors on this profile. So whenever I have patients who exhibit just frank agitation, rage, aggression, combativeness, then I sort of also view these as like emotional, like seizure-like activity in the emotional areas of the brain, but not the motor. Do you see it like that? I sort of see it like that hyperactivity is more like prolonged, seizure activity. What are your thoughts about that, Doc?
No, I know. Most probably the dopaminergic, that's why you want to have, and his language and all those things, important part of this area, so emotional and there, all those things. So I think it's important, so to know, that area.
Well, I know you probably noticed this in my prescribing pattern that I started using dual mood stabilizers, Depakote and lithium.
Yes.
Extended release first thing in the morning. First thing in the morning, right? Have you noticed that?
Yes, I noticed that. Yes, both of the. Yeah.
Have you seen a change over the years? Because I think I started that maybe like 3 years ago or something like that. Have you seen the change in terms of the acuity?
Yeah, I always have a question, but anyway, now you told me, so now I think yes. I was thinking, sometime in the number of medicine you give patients, we're going to take it or not. So I always had a question: one is better or multiple is better? So if the patient know that they need that, yeah, it's fine, But most of the patient, they don't know how many medicine has to take. So that is the problem, So polypharmacy sometimes gets really problematic.
Yeah, well, actually, I'm glad you got a chance to meet me and my team, because what we try to do when the patients come in very agitated or combative, we really try to get them under control right away.
Yes, right. Stabilization.
And then when they get up in the morning, if they agree to take the long-acting Depakote and lithium, then basically those are loading doses. And so I'm trying to really get to a therapeutic dose around day number 3, because I know I'm trying to dial down. I feel like I'm trying to dial down that activity in their temporal lobe, because I don't want them to get up agitated, combative. Yes. And in the rage, because that's going to continue the same cycle that they came in the hospital for, So, and we do that sort of religiously in the morning, so they get there and get it started right away. Do you see a difference on the patients? Like,
yes.
They be nice and toasty.
Yes. But we have a problem with the young patient. But young patient is the problematic. They refuse. They don't want to take it. Then we get the problem. So.
Yeah. It's a challenge. It's a challenge. So let me see here. I'm gonna see about the blood supply. So let me see about let me go through this again. For glutamate receptors, I still use Namenda, because Namenda is very effective for decreasing glutamate activity. So if I have someone with a history of typically maybe a bipolar mixed disorder, combative, agitated, aggressive, I'll always see about adding Namenda if I can't get the agitation under control with the mood stabilizers and the antipsychotic medications. And so And I use basically Depakote and lithium to address the glutamate receptors. So Depakote and lithium will upregulate the GABA receptors. Okay, and our benzodiazepines can be used to treat GABA, to target activating the GABA receptors. So I think it's more of the A site on the GABA receptors where the benzodiazepines bind and they activate GABA, and GABA exerts that inhibitory tone, turning off all the activity in that in the temporal lobe. And here we also have the acetylcholine receptors. The acetylcholine receptors are very effective at helping increasing the person's sensorium. I mean, improving attention, concentration, things like that. So the patients with the very severe schizophrenia, schizoaffective disorder, bipolar disorders, I started putting on Aricept so that I can activate that the acetylcholine system, and that helps with the cognitive impairment. That helps decrease the agitation a lot, Doc. Aricept, yeah. And they have a new antipsychotic out that's based upon the same targeting the acetylcholinesterase receptors only in the CNS, not in the periphery.
Okay.
So the new antipsychotic is a branded medication, but basically it works the same way as acetylcholine, as Aricept. Okay. Now we also have our dopamine receptors, the dopamine 1 through 5 receptors. Now remember, the typical antipsychotics primarily focus on the D2 receptor. So in these cases with temporal lobe, let's say epilepsy or agitation and things like that, if you give a typical antipsychotic, remember, it's going to help stabilize those pathways. It'll bring down the anxiety, but it doesn't target any of the other receptors here inside of the temporal lobe. So we have two strategies. When the patients come in initially, we want to deal with the risk, the danger, and that's when we'll put them on a typical antipsychotic. But then once they stabilize, we want to transition them over to an atypical antipsychotic. And the reason why is because the atypical antipsychotic targets acetylcholine, dopamine, serotonin, and norepinephrine. So with a atypical antipsychotic, you're going to get a broader range of receptors that are targeting things. Okay, so for the dopamine receptors, you can use atypical antipsychotics for these disorders. It's temporal lobe. Here, serotonergic receptors, right? So we're talking about antidepressants, SSRIs, right? Remember the selective serotonin reuptake inhibitors, that can be very effective in treating and stabilizing it. Cannabinoid receptors, these C1 receptors are metatropic receptors. Remember, these are the ones that result in gene expression. Remember, you have the gates that turn on and off due to charges and things like that, and then you also have the G proteins that actually code for products to be produced by the cell body, and then those products are then exported out the cell. So this is the cannabinoids here, neuropeptides like opioid receptors, hormone receptors, olfactory receptors. Definitely for glutamate and GABA, you can use the mood stabilizer Depakote and lithium. For acetyl, if they're diminished in sensorium, very inattentive, unable to unable to focus, you can target the acetylcholine system with Aricept. And with the other receptors, after you stabilize them on the typical medications, then you can switch to atypical medications to get the broader receptor profile to target here. So any thoughts about this, Doc? And then I'm at 29 minutes, so I'm gonna have to go through the blood supply real quick because I wanted to keep it down. Let me just go through the blood supply real quick.
Temporal lobe blood supply.
Okay, can you explain the blood supply? Can you explain the blood supply in the temporal lobe? I'm not going through all this. Got 10 minutes over. So let's see here. Let me just go through the main supply. It's medial temporal artery. Remember this circle Willis? Medial. Okay, let me get to this. Okay. Middle cerebral. Okay, here's the anterior cerebral artery. Coronal. Cerebral. Yeah. So here. So middle cerebral, this doesn't show. Here's the circle of Willis here. So this middle cerebral artery here, this doesn't really show it. That's not a good design to show what we're looking at. Okay, so it's supplied by the middle cerebral artery. Okay, you can read this later. The posterior cerebral artery. Okay. The MCA arises from the internal carotid artery and is the primary supplier to the lateral and superior portions of the temporal lobe. So it's the middle cerebral artery, okay? And here, the posterior cerebral artery. The PCA arises from the basilar artery, okay? And supplies the medial and inferior portions of the temporal lobe. Okay, great. And you can read the other. I don't want to go in too deep into that. I don't think it's going to be on your examinations. So Doc, did you have any other questions before I go ahead and take some questions from the audience at all?
Go on, so I'm still, in the process. So if somebody had a stroke in the temporal area, so their language will be affected if it's in the left, and also the thinking, their mind, what is mostly affected? Their memory or their thought processing will be affected, isn't it? If there's a stroke in the temporal lobe.
Yeah, when I see these type of issues, the communication is disrupted.
Yeah.
But then they seem to behave as if they're unaware that you don't understand what they're saying, and they go on talking fluently, and you don't understand what they're saying and stuff. And so sometimes it's been hard for me to sort of pick that up. But in these cases, and so in terms of that's what I would do as a psychiatrist. So from your perspective, what are your thoughts? What do you do from your perspective when these patients come in?
Their thought process will be like a concrete. This is like not a not a variation in speech or whatsoever type of thing. They talk like different things, different time, different aspects, like all gibberish, whatsoever type of things. Or is just a concrete thinking or speech?
I'm sorry, repeat that again. I didn't get the last part.
If they had a stroke in temporal lobe, so what will be their language? It'll be like they'll be having like a word salad type of thing, or they're just talking stuff.
Or Would you also think of that? I sort of think of that more as a disorganized thought process. So they present with more of a disorganized thought process when they come in with these temporal lobe issues. Yeah.
Especially strokes,
Sounds good. Okay, I'm at 33 minutes. I was only supposed to 2. Your camera is upside down, Dr. Rahman. Okay, okay, great. All right, so I'm gonna go ahead and sign off for today. Guys, if you have any comments, then you can just put them down in the comment section. I'll try and get back to them a little bit later, but I didn't want to go over too far since they're going to stop watching my lectures, so I go too long. Okay, so thank you, Rahman. Thank you so much for joining the show. I appreciate it. Then we'll talk later, buddy.
What's the next topic tomorrow?
See, today, right after this, I'm doing another podcast on, check this out. So I'm... I'm about to start stuff. All right.
Okay.
No, I'm doing a series.
Keep me updated. You just text me hey, come and join.
You may want to join it. So I'm doing a series on narcissism as a network.
Oh yeah, that I need to. Yes.
So narcissism is not an individual. That's just the node.
Okay.
And that network is getting close to you. So the subject is on black narcissistic black family cults. And I'm using the Jacksons as the first example of a narcissistic family cult. And I'm going to do several series on each one of members, like Michael Jackson and things like that. Like, I think your camera just went off. Michael Jackson, well, I guess that's the end of the show. Okay, until then, folks, I'll see you guys later. You have a nice day. I'll be doing my podcast.